Optimization of processing conditions on mechanical properties of polypropylene nanocomposite reinforced with Gigantochloa Scortechinii fiber. Injection moldings are commonly used in the polymer. The advantage of injection molding is for the short production cycle, achievable accuracy, good strength to weight ratio, good appearance and surface definition, highly efficient production, producing a large variety of products with extreme tolerance and intricate shape. The issue in injection molding is the optimal processing condition value, quality, and the additional failure. The objective in this presentation to find the optimum processing condition or mechanical properties is the methodology, the flow. Start from material preparation, primary experiment, design of experiment, injection molding, pressure strength analysis, shrinkage analysis, warpage analysis, and using Anova. Why we use and choose the clay and the fiber bamboo is because good availability, relatively easy surface modification possibilities, low in price. Mixing method, the mixture of the PP clay was formed by using the twin screw brabender with melt temperature setting of 170 degrees Celsius with the speed 154 revolution per minute and 10 minutes of minutes. This is the composition of formulation for the three different composition. The difference is the weight ratio of the fiber bamboo percentage and the polypropylene. For the composition number 1, we use 0 fiber bamboo. For the second, we use 3 weight %, and the third is 6 weight % of the Gigantochloa Scortechinii. We choose the cloisite 20 in nanocomposite because the cloisite 20 is matched with the polymer metric. As this show the shape of the cavity dimension, we use the mold shape to run the test. Okay, the next is the factor we choose the 4 factor. First is melt temperature, baking pressure, screw speed, and bend time. With the different level, we use 3 different level from the lower, medium, and high. For the melt temperature, 165 degrees Celsius for the lower. For the middle is 170 degrees Celsius, and the high is 175 degrees Celsius. For the baking pressure, the lower is 30%, and the middle is 35%, and the high is 40%. For the screw speed, we choose the 25%, 30%, and 35%. And the filling time we choose is 1, 2, 3 seconds. 1% of baking pressure equal to 1.6 megapascal, and 1% of screw speed equal to 2.4 revolution. This external array have run by using the mini tab, the Gucci method. We have R934, which is this. We have 9 drivers and 4 factor. Okay, for the result shows is the pressure strength for all composition from 0% of the natural fiber, 3% of natural fiber, and 6% of natural fiber. According to the result, 0% of fiber, the larger percent contribution was fill time, which is 78.42%, while melting temperature to 15.5%, and the lower percentage was baking pressure and the screw speed with the same value, 3.04%. And for the next composition, 3% percentage of the natural fiber. The highest value was the melt temperature. The highest value type due of for the 3% of Gigantochloa Scortechinii, the highest filling was filling time which is the value is 3.48%. The lowest is packing pressure, and the time fill time is 5.34%. And for the melt temperature for the 3% of natural fiber is 35.84%. For the 6% samples of veggie strength for the melt temperature is 31.84%, and followed by the screw, followed by the fill time. 31.84%, and the next is screw speed to 8.45%, and the lowest contribution is 19.86. This is the result for warpage. 0% natural fiber. The melt temperature is a high percentage contribution, which is 72.21%. The lower is 5.23%, which is the and the next is filler time is 17.13%. For the 3% of Gigantochloa Scortechinii fiber is indicated that the temperature parameter A contributes to the highest percentage, which is 39.09%, while the for filling time was the lowest one is 19.29%. The parameter of packing pressure and the screw speed is the between high and lower percent is 20.81%. For the 6% of natural fiber is the packing pressure, and the screw speed with the higher percentage is 44.44%, and the next is the filling time 0.5%, and the melt temperature is at the most at 10.6. Okay, for the discussion, as a regards the percentage value is appears that all injection molding parameters contribute to the finding of this study. According to Elsabak et al., increasing the holding pressure of injection molding could improve the mechanical properties of composite. This was due to the resulting crystallinity of the polymer molecule chains and the oil tension of the fiber in the context. The increase in the injection temperature after time during processing contributed to lower composite mechanical performance. All parameters are interrelated with each other and the injection molding processing. According to the paper from the Hilmi et al., the melt temperature is slightly less effective on the shrinkage of the injection molding. Nevertheless, the researcher Altan et al. Stated that the melt temperature was considered more important than holding pressure to minimize shrinkage. According to another researcher, to minimize the shrinkage in the injection molding are difficult to discover. This is because it depends on the material and the composition of pellet has been used. The researcher attempt in his finding was that the vacuum pressure is the most important parameter needed to control and minimize. As a conclusion, the Anova analysis with the high percentage of the quality endpoint provide the best sample in the conclusive way. The objective of this study was achieved for the parameter that influence flexural strength, shrinkage, and warpage. Other than that, to make the effect of increasing in the quality of the natural fiber in the composition also being accomplished by the changing of thermal setting with respect to the parameter that result from the combination of the best setting. After completing this experiment, variable experience from the different aspects are required. Among them have been field tests on the injection molding machine and also include the running circle of the injection molding machine. This will increase the knowledge of how to use other machines that have not been used.